So the first person who's going to talk tonight is Clare Seesman, and she is our expert, along with David Bailey, who can't be here tonight, on the wetlands. And so, hit it, Claire.
Welcome for those of you who I've never had the pleasure of meeting. I'm Clare Seesman, also sometimes referred to by people who have known me for a long time as Nami, Saring, more recently, the other Claire, Claire 2. You can call me any of those names, I'll answer. But no, really, that's just an icebreaker. I'm here today to tell you a story about clean water in our environment, how we have historically purified our wastewater at KPC, Maryland, and how the recent major upgrades from what was already a unique and environmentally conscious way of managing wastewater are the grand start to our future development at KPC, Maryland. So this is an opening shot of one of the wetlands cells at KPC. So every building, as you know, every building that has bathrooms, sinks, and toilets needs wastewater treatment. In other words, the wastewater has to go somewhere and be cleaned before it's released back into the natural environment. The two most common methods in the United States are, one, to be managed by a municipal system at a wastewater treatment plant that uses a combination of biological and chemical treatment. Two main ways that most common methods that we can manage wastewater are a municipal system like this one that I'm showing. It's a big wastewater treatment plant owned by private companies that use a combination of chemicals and biological processes. Then you can also use a septic system. As KPC is located in a more rural area, it's too far away to connect to the municipal source. So for wastewater treatment, KPC initially used a septic tank like this one, which led to a French drain system filled with gravel and tile. This was meant to slow down the wastewater and filter it some before it proceeded to the soil to be filtered further. In theory, the system should have worked just fine. Unfortunately, around 1988, this system failed because the soil type, which is dense red clay base, did not have the capacity to receive and filter the wastewater. Wastewater started coming up from the soil below the main temple septic tank and flowed down the hill. This was unsanitary, environmentally impactful, and in violation of Montgomery County regulations. This is because elements in wastewater, agricultural runoff, et cetera, cause a process called eutrophication, which you don't have to get into the whole scientific process. This is a little diagram, but it can harm the waterways and wildlife. We, of course, want to keep our waterways clean. This is the Potomac River, which we are very close to. So fortunately, at this same time, David Bailey started coming to KPC and heard about the problem. It just so happened that Dave worked for one of the local power companies, PEPCO, where he was in charge of a wastewater discharge permits and water issues for PEPCO's power plants. Just the year before, David had attended a industry environmental conference where he heard a paper presented by the Tennessee Valley Authority, which addressed the problem of wastewater from properties that were located around their local lakes and causing algae blooms. Oh, that's the wrong one. Through that process of eutrophication that I just mentioned, so to address the issue, TVA developed a design manual for constructing a wastewater treatment system, which consisted of shallow ponds filled with gravel to support wetland plants. The plants filtered the water and removed nitrogen and other pollutants. Using the manual that TVA provided, Dave designed a constructed wastewater treatment system for KPC. Engineered design drawings had to be prepared by an environmental consulting firm. Dave knew of one through his work. Then Dave met with local officials from Montgomery County to discuss the project. But it wasn't as simple as just installing the system because it was so unique, so it didn't fit into their usual regulation boxes. They had to confer with multiple other regulatory agencies, such as the State of Maryland Well and Septic Department, Maryland Department of Environment, and the Federal Environmental Protection Agency, we call the EPA. The system would need to be permitted and monitored according to the Federal National Pollution Discharge Elimination System, NPDES, their program's environmental and human health and safety standards. Finally, Montgomery County decided that permitting of the KPC project should be handled directly by the Maryland Department of Environment. And Dave knew the director of MDE, of wastewater treatment programs. And he arranged a meeting to present the wastewater treatment system design. MDE agreed to issue a permit for the project. In 1989, construction of the treatment system was initiated and overseen by David Somerville, who ran his own construction business in Maryland at the time. The initial plants were donated by an aquatic nursery in Maryland. This is a picture of David Somerville and another volunteer. And David Somerville, this is shows the style of the times in the summer working. And then, so this is shows one of the first wetland cells, raking out the gravel and everything and prepping the area. This is David Bailey. He's sorting through some of the plants that needed to be planted, and some volunteers planting. Okay, and so this is what they installed. So this system, it has a septic tank housing. So I think you can see my cursor. Is that correct? Okay. So the water flows from the temple through a pipe into a septic tank, like we showed before. And then instead of going into a septic field, it also comes from the lineage house. And here's the pipe from the lineage house. And then instead of going into a separate septic field, it goes into these wetlands, bays, or ponds. They're not really fully filled with water all the time. You can't see the water, so it doesn't look like a standing pond. But there's 1, 2, 3 of those. And it also includes, there's manhole covers where these orange dots are. And there's adjustable stand pipes to control the flow of the water between the cells. So the water flows down into the first one, and then you can control the flow so it can go more or less into the second one. And then you can control the flow so it goes more or less into the third one. Then it went into a concrete aeration filtration tank. And then it went through a UV crystal sterilization process. So all of this was to meet the requirements of the system to turn it into clean enough water to emit back into the environment, and then it just flows out into a gully right here, and then joins in with the rest of the water stream in the natural environment. So it's a very unique and somewhat technical system, but it takes a lot to manage a system like this. So basically, what needed to happen, like there's daily checks that needed to happen. Daily, the filter in this tank needs to be checked. The UV crystal lights need to be checked, and if it freezes, the whole system has to be shut down so that these crystals don't freeze and break, which we had happen one time because we lost power. So there was no power going to the system to keep everything going and warm. We had to check the water level in each one of the cells and use these stand pipes, which I'll show you in just a minute, that are under these manholes. We had to prop them up or put them down. So lift the manhole cover off and then put them up or put them down to control the flow of the water. And there was a lot of, there's measuring the flow at the end of the system. You had to put a bucket under and count so that you're measuring the flow. We could only release 3,000 gallons per month, I believe. into the environment. Anyway, it was, each thing is regulated to make sure that, that it's not releasing toxins into the environment. So all of the permitting and reporting, we had to keep a log, and we had to monitor, like I said, every day, every month, different things we were monitoring, and submit those reports to the MDE and make sure that we were in compliance all the time. And then if we went out of compliance, we had to fix it within 24 hours, things like that. Fast forward to 2009, and I moved back to Maryland from Arizona, where I'd been studying ecological design and working in the horticulture industry. And Ani Dawa and David Bailey approached me. Over the years, multiple people, David Bailey was the primary operator. He had a license to operate the system that's required by MDE. And he had volunteers helping him do these daily checks and such, because he lives like 40 miles away from KPC at the time. So driving back and forth, he did, really often, most of the time. And then so many volunteers, I'm not sure how many actually, but I've heard people say, I used to help with the wetlands and do the daily checks and things like that. So this took a good amount of effort from people. So Dawa and David Bailey approached me and asked if I'd like to not only help monitor, but eventually become an operator of the wetlands. And so I didn't really know what I was getting myself into. And of course I said yes. So then I started to learn about this system. So under those manhole covers that I talked about, this is one of the stand pipes, and you can see the water flowing out of it, and that pipe moves. So you have to, like I said, take off the cover of that and move the stand pipes if the water needs to flow differently. The water flows through those ponds and into this concrete tank first. Then that has a fabric filter, which we always checked to make sure, and if it needed to be changed, we'd remove the fabric filter and put a new one in. It also has aerators. Those aerators bubble and help the water with dissolved oxygen, which is one of the things that we needed to test for. And then the water would proceed into the UV sterilization unit. There's, this is the housing for it, and so there's crystals that run along it, and the water goes through there, and that sterilizes any remaining bacteria so that they cannot reproduce in the environment. And then this is the little shed that housed the septic tank, and you'd have to go in there and check the septic tank, make sure that it was clear and flowing properly, if it needed to be pumped occasionally. So like I said, lots to do, daily checks, monthly checks, and reporting and testing. And those things that we had to test for were like dissolved oxygen. There's very scientific tests, which we used a meter for, and the aerators, the bubblers, aerators helped a little bit with that. Total suspended solids, we had to take a sample to the lab, ammonia and nitrogen, and we had to also take the sample to the lab along with biological oxygen demand, E. coli, and pH, which we used a pH meter. So I can't remember which year, but along the way, I believe it was in maybe it was late 2010, 2011, I went to the classes to become an operator, and then had to take an exam, and I was certified as an operator. So I was working under David Bailey as an operator, and certified by the Maryland Department of Environment. So let's see, we went to all these. Okay, so overall, the system operated successfully for 30 years until it had to be shut down in 2015. MDE had changed the nitrogen limits from 14 milligrams per liter to 5.5 milligrams per liter. So that was a drastic drop. It was about a third of what we could have nitrogen that we could have coming from this system in the water. So we turned the system off. Water was still flowing into the wetlands. We turned the system off, and at the bottom, we had that pumped out quite frequently instead of discharging the water into the environment. So how were we going to proceed from this? We learned that what we needed was a special nitrogen removing tank. Very unique as well. Special had to figure out who was going to install it, how it was going to be installed, also needed engineered drawings and permitting and things like that. So we went on a search for the team to do that, and we found Hydroterra along with Hatfields, who was helping pump the septic, and together they said that they could do the work. It took several obstacles, even getting the very unique tank, ordering it, having it, delivered through COVID, through, all kinds of things. There was the permitting process, et cetera, et cetera. So many hoops to jump through. But we finally found the team. This is some of the Hydroterra and Hatfield team. So the first thing that they had to do, so this work just started in early December. And so it's already been in full swing. They're just doing finishing touches now. So the first thing they had to do was remove the old septic tank that I showed you on the drawing. It wasn't functioning properly. So install a new one that was better and will last for years and years to come, well into the future. So this is them digging the hole for the new septic tank, which is a little bit further down, and I'll show you a diagram later. So this is the hole for the new septic tank, and this is them installing just the new septic tank. This is our hoop house where we grow vegetables in the winter. So then they had to install the nitrogen removing tank. So this is them doing the groundwork and digging for the new nitrogen removing tank. And this is the first wetland cell. So this is very close to those wetlands, ponds or cells. Big machines, big holes, very, very large holes, because it had to fit this tank. So this is the nitrogen removing tank. It's quite impressive. This is the crane that had to be brought in to install the nitrogen removing tank. Massive. And this is the insert for the nitrogen removing tank. And so this doesn't just remove nitrogen, it actually filters all kinds of particles. This circular thing or oval thing on top is a big aerator. And so again, I mentioned we have to have a lot of oxygen in the water for all of the biological things to work, they're magic. And so that's a big aerator. And then there's this kind of honeycomb filtration system, and that filters through so much of the water. Actually, this tank system itself, the two tanks, could handle the capacity well into the future, even if we built new buildings, even if we disconnected it from the current wetland system. So with that said, basically, this entire system is extremely environmentally friendly. and will hold a great capacity and well into the future. This is another picture of the inside of the, this is kind of turned on its side because they haven't installed it yet. So this is just kind of a close-up of how interesting it is and for scale. Okay, and then this is, they put the tank, the big nitrogen removing tank, into that large, very large hole. So much work. And they're just putting the lids on. And those are things that can be, you know, adjusted. The system can be cleaned out if necessary. It won't require that very often. And this is where that little shed used to be. And so it's no longer in sight, and it was really dilapidated at this point. And so that entire septic tank was removed and the shed was removed. And so this will become lawn or meadow. So that will be the view. So they still are working on some of the little technical details, but this was the tank. So there's the aerators, but they're installing more aerators, stronger aerators, and filters, and then another aeration unit that recycles the water back up into the nitrogen removing tank, so we can actually filter the water multiple times. Again, this water is going to be very clean when it goes back into the environment. And then, you know, new lids and everything new on all of these units. So in those manhole covers, I talked about having to stand those pipes up and down and lift the manhole covers. These guys actually invented a unique system. So it's like a float valve type of system, so that those levels will regulate on their own. We'll still check them, but we will not have to. This is eliminating a lot of volunteer work that we're going, you know, that we had to do in the past to keep the system running. And in fact, this company is also going to help us monitor the system. So they're installing various things that are reducing a lot of that extra work and making the system way more efficient. So this is one of the wetlands ponds. It's winter time. They've just, you know, just kind of graded all of this. This is what the plants look like in the winter. And so this is a diagram of the new system. So as you can see, they removed the old little septic tank. I wish I could make this bigger. I can probably. Let's see this. There we go. Hopefully you guys can see that a little better. Okay, so this does not look as crisp as what I thought it looked like before. But again, this is you know, the new tank, then the new nitrogen removing tank with all of those filters. Like I said, it does way more than just remove nitrogen, other particles and everything like that. And then it still flows through the wetlands. They've invented these automatically adjustable float valves, and then still goes into this filtration tank, the UV crystals, gets aerated again, and then can go back through the system and be recycled. But whenever it's ready, we can discharge through here, through the end again. And they're also installing some monitors that are low tech enough. Well, this was very important, is that it's a low tech enough system that we at KPC don't lose track of what is happening. We still know what is going on in the system. We can still troubleshoot, we can still manage. That's very important. So it's low tech enough that we're able to do that and continue that well into the future. But it has high enough tech that we'll be able to reduce a lot of that volunteer labor. So how does this affect our development in the future? This is the beginning of anything we want to move into the future at KPC. So, we will probably be growing and developing, possibly, hopefully building new buildings. This system is built to capacity way into the future, much, bigger capacity than we had before, very environmental. And so we've started the capital campaign, and basically this is the beginning of our new temple development. So we've started moving into the future, and it's very exciting. And this will help us be environmentally friendly with treating our wastewater, and have, more kind of control's not the right word, but we're capable of managing all of our wastewater and being environmentally friendly into the future. I'm not quite sure how to end, but I do want to say one important point is, if anyone ever has any questions about this entire system, please just direct them to myself or Claire Wagner. Don't attempt to relay any of this technical information. It could get confusing. So, always happy to answer questions, Claire Wagner or me, the other Claire. And in fact, I think at the end of all of the presentations, I'll stay on. So if anybody has any questions about this system, what it means, what we're doing, then I'd be happy to answer those. So thanks very much.
So thank you, Claire. That was a really great report. David Bailey and Claire have been, since the very beginning, 30 some odd years ago, this is a state-of-the-art, really unusual project. It always has been, and it remains to be the only wetlands that isn't functioning right now, but was for a very long time, and the only one in the state of Maryland. So it's a very special project.